Hi, welcome to my class, Advanced Math Theory and Proof. Let me open us up in prayer. Lord, I just give you thanks, and I ask that you give me wisdom this year on how to instruct each and every student, Lord. I also pray that you give the parents wisdom in helping them help their children navigate these times. In Jesus' name I pray, amen. Well, I want to just tell you quickly a few things about Advanced Math Theory and Proof. And if you have extra questions afterwards, you're welcome to email me or I can call you back if you'd like. So, Advanced Math Theory and Proof. First, a little bit about myself. My family here, my children, I have two girls here. They're in 2nd and 6th grade. When I'm not teaching, my favorite hobbies are to read and when I'm healthy, play some tennis as well. Here's the best way to contact me if you ever have any questions. Some other things about me professionally is I have been in math education now for over 25 years. I was in college 9 years, either working on degrees in math or in math education from 4 different universities. And for the last, I've done a lot of things, such as I worked in a professional development group for San Diego State University for years. And then for the last, this is my 13th year now, I've been here at Santa Fe Christian Schools, where I've taught classes such as AP Calculus, Linear Algebra, Advanced Math, just to name a few of them. About 4 years ago, the largest math organization in the United States of America, the Mathematics Association of America, I was awarded their National Teaching Award, one of 20 students, 20 high school teachers, who was given that award in 2016 for the work that I did in motivating students to become very good problem solvers. So this class, the vision I had in creating this class was to help students become, number one, better problem solvers. That I see problem solving as one of the most important things we can try to help our students become while they're here in high school. But some other major goals I have for this class is that they learn high school math really well. This class gives them a chance to look at topics they've learned before and to become even much better at those topics than they ever were by solving really interesting problems where they have to bring in lots of those ideas to solve a single problem. We do that all the time. But I also wanted to prepare them for the most math-intensive programs in the most select universities in the world, so that if they go off to even a Stanford or MIT or Caltech, which we send plenty of students to, that they will have the mathematical background to be successful in any STEM program that they may end up going to. So this, for instance, is this came from a college counselor when we were trying to create this class, and we were shooting out some ideas, and they gave us this input. They said, hey, when I was a freshman at MIT, I felt at a disadvantage because kids at some schools had access to high school classes such as linear algebra, differential equations, and multivariable calculus. I had aced Calc BC and AP Stats, but we didn't have anything else at our school. So incidentally, kids that made me feel the most insecure were those who went to schools such as Thomas Jefferson in Virginia, where they had a leg up taking all these classes, and thus were able to start undergraduate research earlier. And by creating classes like this advanced math, and we also offer linear algebra here at this school every other year, our students who now have gone off to schools such as MIT have come back, and we have dozens of them. We have math team reunions almost every year so that I get to hear from them. And literally dozens of students have come back and said, yes, we feel like we were ahead of the game at these most selective universities because of the mathematical background that we were able to have here at Santa Fe Christian, including the background they got from the advanced math class. Our textbook, I love this textbook. It's one of my favorite math textbooks. I've taught from hundreds of math textbooks over the years. This is one of my favorite ones I've ever seen. The authors are amazing that wrote this. In part, they just put together such a great collection of really interesting math problems to solve that really make students think and reason, and they're not obvious. But I also like about the way that it's put together because, again, the chapters take us through topics that the students are familiar with, but the problems are so much more interesting and more difficult to solve than anything they've seen before, which helps them to become, again, excellent at mathematics that they're supposed to master in high school. But it also has a survey of advanced topics, such as number theory, the pigeonhole principle, mathematical induction, and complex variables, to name just a few topics, where they're getting an introduction to these topics that, by knowing these before they go to college, they'll have a leg up on the other students at that college. So an example of some of the kinds of problems that we solve, or for instance, one of them is, these are actually problems from the textbook, triangles in geometry. Use the law of sines to prove the angle bisector theorem. So we do a lot of proofs. And in this case, we're actually showing how one idea, the law of sines, relates to another idea, the angle bisector theorem. And I don't just present the proofs. Most of the time, the students themselves are actually developing these proofs so that they really understand where these ideas come from and how they're related to other ideas. Conics is something they may have a little familiar with, but we take it a lot farther. So there's an example of the conics problem. And actually just today in class, we started learning about number theory, which is a fantastic topic to have a familiarity with. It's one of the actual big topics of mathematics that rarely gets touched in most K-12 schools or most high schools more specifically. And this class gives us a chance to touch on that topic. Now, when it comes to colleges, and especially select colleges and STEM majors, if you look at what's going on with the SAT and the ACT these days, a bunch of students get either a perfect score or come very close to a perfect score in mathematics on the SAT. I mean, the year I looked this up, there were 12,000 students that got a perfect score on the SAT. And we have often a dozen students who will get a perfect score on the SAT math, if not the SAT math level 2. So when you're talking about your more select colleges, how are they going to distinguish between good and someone who's really good in mathematics and mathematics problem solving? And the answer for many of them has been the American Mathematics Competition. It's the largest math contest in the United States of America. Here's some examples of problems. It's way more challenging. It's harder to get half the questions right on an AMC than a perfect score on an SAT. And so I mentioned this competition because we've been taking it since 2010. Now, we didn't have an advanced math class back there. And on the AMC, while only the better students in the US will attempt this challenging exam, usually about anywhere from 50 to 100,000 students will attempt it. The average score on it usually is somewhere in the 60s. So you can see these were our top 10 scores the first year we took it. We had some students that were scoring with the better students right along with them. But if you can score up around an 85 or above, that ranks you in the top 3,000 in the US most years. And so really, if you can get up to that level, that really is now starting to distinguish you. A year later, we had a math club, and we started to get some better results as kids were starting to do some math in our math club. You can see that we're now starting to get a few students who are getting close to that top 3,000 level. But in 2011, 2012, we also had our first year teaching the Advanced Math Theory Improved class. And that actually got us a humongous boost in scores. Now we're really starting to develop some students who are becoming very good in math. Our program only continued to build on itself, and only 4 years later, we now have a lot of students by 2016 who are scoring among the best in the United States. These students up here were actually ranked as high as 314th in the nation in the United States of America. And to look at where these students are ending up, I mean, this is all students who did well. These are actually colleges that just in the last 4 years our students have got on to, come back and visited and said, yes, we're doing phenomenal at each and every one of our universities, whether it be a Harvard, a Stanford, a Princeton, Wharton, and many other colleges. So our students are not only getting into a lot of really great colleges, but the biggest and most important part is that they're coming back saying, and we are prepared for the challenge that these colleges are providing us. So I don't want to make this too long, so I'm going to skip a few things that I might sometimes share and just go to one last thing about this class that I want to tell you. And that is, this class is, for most students, often the very first time that they've really been challenged in mathematics. And it's very rare that there's a student in this class that won't tell you that I'm really being challenged every day in this class. But here's what I want to leave with you. Based on much of my reading that I've done in the last 10 years, I've come to these conclusions when it comes to learning, not just mathematics, but it definitely applies to math. That number one, people often overestimate the significance of intellectual ability. That way more people are able to actually achieve greatness in things such as math if all they do is really put in the practice and perseverance, and often having a good coach is very helpful in that process too. So having an IQ of being brilliant, it helps a little bit, but really it's the self-discipline part and working hard that's going to make someone successful. And we're all finish off then is to say that I want every one of my students to improve a lot. They're all starting in different places in their problem-solving experience, but I believe every one of them can make massive improvements no matter where they are, and that is my goal for each and every student. So anyways, thanks for visiting, and enjoy the rest of your videos you see tonight.